Representation of continuous time signal in terms of impulses. So here we are going to represent a continuous time signal in terms of impulses. So any signal which can be represented as a weighted superposition of time shifted impulses. So let us consider one signal x of t. So I am going to draw that one. Say my x of t with respect to t. So let us assume the signal is like this. So let us consider a point on x of t. So that means I am considering a point on x of t. So at t equal to tau, you can call at t equal to tau. So that means at x-axis, so tau we have written. So now, let us assume its amplitude is a, capital A. So now we can find the area under this point. So I can call here area under this point is nothing but width into height, so that gives the area. So here the x of t, so that gives the height here, so along y-axis. So x of t into delta of t minus tau. So delta of t minus tau we have used because already you know the impulse function. So impulse function which has infinite height theoretically, and its width is nearly equal to 0 and its area equal to 1. So now, based on that, we have chosen here time shifted unit impulse function delta t minus tau. So it gives its position and also width of this, so nearly equal to 0. So and x of t, so that gives the height, so that is nothing, total area becomes a. So because delta function area which is equal to 1, so 1 into x of t, so its amplitude is a, so height, so now its area becomes a. So now we have represented single point, so that means I can write in this way also. So x of t into delta of t minus tau, say it is located at tau, so its amplitude with arrowhead I am writing. So that means, this can be written as, look at here, so this x of t into delta of t minus tau. So let us see the product property of impulse function we have discussed. That means if it is x of t, I can write here x of t into delta of t. So then I can write here x of 0 into delta of t. Similarly, time shifted delta function, if I take t minus t naught with x of t, so then I can write here x of t naught into delta of t minus t naught. So that is the product property. So based on that, I can write here this as a x of tau into delta of t minus tau. That means we have represented a single point, so in terms of impulse function, unit impulse function, so that is a time shifted impulse function. so which gives exactly the position of this point. So and x of tau, the signal amplitude. So actually your x of tau is nothing but a constant here, so that gives the amplitude, so that is nothing but a. So now if you consider this x of t signal, so it has infinite number of points. That means starting from here it has infinite number of points. So we can look those points, those are very closely related. So then I can represent this entire signal x of t, so in terms of delta function as a, so x of t equal to, so integration of minus infinity to infinity, so x of tau to delta of t minus tau d tau. So integration we have taken because the signal x of t is continuous, so it has infinite number of points. So single point I have represented as a x of tau into delta of t minus tau. Similarly, if it has infinite number of points are there, so if I add all those, so then I am getting a my signal x of t. So the integration does that operation. So hence it has infinite number of points. So I have taken it as from minus infinity to infinity x of tau delta of t minus tau. So with respect to tau. So this is how to represent any signal, any continuous time signal, so in terms of time shifted impulses. So that means we have represented a continuous time signal in terms of, that means weighted superposition of time shifted impulse function or time shifted impulses. That means x of tau, so it gives the weight. Suppose if I consider one more point here, its amplitude is different, so x of tau, so it is a constant quantity you can call here, so that gives the amplitude. So delta of t minus tau, which gives the position, so exactly which position, so that impulse function is located, so at that point, so your x of t signal is evaluated. So this is the representation of a continuous time signal in terms of impulses.